Welcome. For those of you viewing this recorded presentation and discussion, thank you for your time and interest in the project. We know that there are a lot of questions out there about the different aspects of the project that you would like to get a better understanding of as you develop your teams and your strategies. I'm certain that today we're not going to be able to answer all of your questions, but we do want to try to address the questions that we've heard most frequently. Also note that with this presentation, we are also releasing the Conceptual Design Report, referred to as the CDR. The CDR essentially outlines the basis of design for the project and will allow you to understand the decision-making process that has gone into the overall project development. Design build teams may be thinking of options that the CDR has already addressed, or conversely, may not have been addressed at all. It will give you an understanding of how the project has evolved to this stage that it is now and what unique elements your team may bring into this development. As the owner's representative, our goal has been to bring the design of the project to a nominal 30% level of completion that will allow each design build team to take this design to a point where they can develop their own fixed price for the project, which by industry standards is generally referred to or considered about a 60 to 70% level of completion. There are design disciplines that will be both more or less than a 30% level of completion within our design, depending on the depending on the district's preferences and level of prescriptiveness for each of those components. Our intent here is to give you a high-level understanding of where that level of completion is headed so that you may incorporate that information into your strategies and approach as needed. And with that, I'm going to ask Alan Christinell, our engineering manager for the project, to discuss the major equipment that will be included and our overall conceptual layout for the project. Alan?
Yeah, thanks, Bentley. Appreciate the chance to talk to everybody here. So just really quick, I'll kind of go over kind of our agenda for today's presentation and kind of what we expect to do in terms of our concepts and ideas that we want to present for everybody. We'll define what the components are of the RFP, the request for proposal documents, and what you can expect to see when that gets issued. We will review the different various design disciplines, level of completions that we have for those, and kind of what our goal is for providing various levels of design for different disciplines. There will be a 3D Revit model that we are preparing that we will make available to design build teams. When the RFP comes out, we will take a brief look at some of the components of that. And then, like Bentley just mentioned, we'll close with a little bit of discussion about the conceptual design report.
Okay.
So one of the major objectives of this presentation is to describe and define what you will see when the request for proposal comes out. It will primarily be composed of these different items here. It will include a set of drawings, and the drawings will be composed primarily of some process flow diagrams, some plan sheets, and several discipline specific design schematics and diagrams. We will complement those drawings with both design guideline sections as well as full technical specifications. And I will discuss each one of those a little bit later on in the project or in the presentation, but a design guideline section basically will define what we expect as the owner's representative, speaking for MSD, in the quality, in the performance, and on the overall reliability of the project. And we'll give criteria and codes and standards for a lot of that. The RFP document will obviously also include contractual documents, which we are still working on preparing. And then the RFP document will also include reference documents. One of the things that we have been asked a couple different times now is how many drawings, as-built drawings, construction drawings are available of existing facilities at both Bissell Point and Lemay. There is a lot out there, a lot of volumes of drawings. A lot of them are pretty good. A lot of them are not as good, but we will figure out a way to make all of those available to the design build teams when we get ready to issue the RFP.
Okay.
So as we all know, this is essentially a large solids treatment project. And for solids treatment, it primarily composes of two processes, a dewatering process first, followed by an incineration process. The dewatering process is going to be the same for both plants, Bissell Point and Lemay, and will consist initially of receiving existing sludge, existing waste activated sludge and scum into blended sludge wells. These essentially will replicate what they have at both facilities now, with the exception of these have to be new because essentially the old ones will go away with this project. From those blended sludge wells, the raw sludge will be pumped up to centrifuges. Centrifuges will be the equipment and the technology that we have decided to use for the project for dewatering. 8 centrifuges will be provided at Bissell Point, with 6 being provided at Lemay. Discharge from the centrifuges will go to incinerator feed bins, and then from those feed bins, hydraulically driven piston pumps will pump the sludge cake from the bins into the incinerator reactors. There will be 2 pumps per each bin. So as you can see, that's 8 pumps for Bissell Point and 6 for Lemay. Associated with all the dewatering process will be a polymer feed system. We will also provide 1 per plant, a sludge cake receiving station. So there will be the opportunity for each plant to receive cake trucked from a different facility and then processed at the receiving facility. And then the opposite will also apply. Whereas if something needs to be trucked from, as an example, Lemay, we will be able to pump the cake into a truck and then haul it from Lemay to another area in the event that there's problems with incineration, some peak load conditions, things of that nature. And then with all of that, there will also be an odor control system provided.
Alan, one of the things that some design build teams may be inquiring about or have concern about is that you may comment on is whether or not there is flexibility within this design for the design build teams to offer any alternative proposals.
So one of the things that we really have had a chance to talk about is there are certain components to the project which we feel are essential to the project's success. Are essential to the district as the end user being happy and confident that they'll have long-term reliability and success with the project. And we will essentially fix those components. And frankly, a lot of the items that are shown on this slide here are those such items, major process equipment. But there certainly will be other opportunities for the design build teams to propose something different, and they'll have the flexibility to do that. Won't be on these more major, more significant, more project critical items, but items such as pumping, metering, valving, a lot of piping considerations. Those are certainly the items on the electrical side as well. Those will certainly be items that there'll be some flexibility for them.
One of the things that the design build teams should keep in mind is that the RFP process will include an alternative technical concept component to it, ATC process. This will include both global modifications that may be accepted and communicated as a scope change, or it may include options that are confidential and unique to each individual team. The district will obviously make that call based on each ATC submittal. And should a team submit something that they believe is confidential to their team that the district determines is a scope change, that team would then have the opportunity to retract that ATC submittal. But if it is accepted as a confidential change, that could be a component that allows each design build team to differentiate itself. So I just want to point that out. So Alan.
And this slide will just show a typical example of something that we will provide with the RFP. This particular item is a process flow diagram. One thing I want to point out about this drawing and any of the upcoming slides that I have during this presentation is all of this is still a work in progress. And certainly all of this is still subject to change. So this presentation, these slides will give you a good idea of where we're headed on this.
Right.
But certainly it's not done yet. And certainly there is the chance, and there likely will be things that change from what you see today. So I just want to make sure that everybody is understanding of that before we get a lot further into the presentation. But this will be a typical example of what we provide for a process flowgram. In this particular situation, it just shows what we see as being a functional means for dewatering and sludge conveyance prior to incinerators. We'll have other process flow diagrams for other components of the process, and those will be used in the RFP documents.
Okay.
So the next phase of the process is obviously incineration. A lot of this particular item has already been released in various other presentations, but so we all know that the incineration process will be fluidized bed reactors. 4 incinerators will be installed at Bissell Point, 3 will be installed at Lemay. All of them will be at a capacity of 83 dry tons per day. And what this 4 and 3 arrangement does is it allows them to have max month capacity +1. So in the situation where they are at a peak capacity treatment at a plant, they will still have 1 train on standby for whatever reasons, be it maintenance or something else is kind of going out of whack. So the bullets kind of provide a lot of the different components of the fluidized bed system. I think most everybody in different presentations has seen a lot of this already. One thing that I did want to point out is we will be using the existing ash lagoons at both treatment plants as the end, essentially the end means for ash disposal. Ultimately, it'll get hauled away, but essentially end means. But for the Bissell Point facility, there will be improvements that are necessary to those ash lagoons. The floor of those lagoons have a tendency to allow infiltration, groundwater infiltration when the Mississippi River is high. So part of this project will be addressing taking care of that groundwater infiltration into those lagoons at Bissell Point.
Alan, one thing, understanding that a lot of this equipment is obviously very prescriptive. What opportunities or what components of this equipment is essentially locked down, and what may still be revised as we go forward?
Well, touched upon it a little bit, but these major process equipment, these things that are really considered to be successful parts of the project, are going to be locked down. We will have a very technical spec that defines essentially a complete technical spec that defines the fluidized bed incineration process. And we will have a complete technical spec for all these different components of the fluidized bed system. The same applies for major components of the dewatering system, such as the centrifuges, such as the piston pumps. To make sure that everybody gets what we want in terms of the district and everybody is happy that it's going to last a long, long time and be successful, we felt it appropriate to really lock down some of these items. Now, for minor items such as valves and motors and stuff like that, there will be flexibility, and I think there's opportunities to do a lot of things different there.
Gotcha. All right. Thanks.
So again, an example of a process flow diagram. This is for the incineration process. It will just give a big picture layout of how all the pieces fit together and just how they all interrelate to each other. Again, just to provide a big picture concept of the process and what we see we need to have to make this a successful project.
Okay.
So this is a big project, high capacity equipment, large equipment. Everything that we provide under this project will be housed, and all the ancillary equipment as well, in what we're referring to as a solids processing building. So there'll be one building per each facility. Like I mentioned, it will house both the dewatering processes as well as the incineration processes and anything else associated with those. To put it rather simply, there'll be a dewatering half of the building and there'll be an incineration half of the building. The dewatering half will be multi-levels, multi-floors, starting with a basement level, which is where the sludge receiving tanks will be. And then there will be the upper level, 3rd floor, so 3 levels above grade. That will be where the centrifuges are located. And then the sludge cake, as it works its way through the system, will pass down to intermediate floors and then ultimately make its way into the incinerator half. And then the incinerator half of the building is going to be different than what you all have seen when you've had the chance to go out to the sites and look at their existing incinerator complexes. Those have multiple floors with a checkered plate floor or concrete floor. This will be an open bay concept where the reactors and all the equipment will essentially sit at grade and then rise up into this open bay. It'll be multi-levels tall, but there will be no intermediate floors per se. Now there will be walkways, there will be platforms to get to key parts of these facilities that require access, require maintenance. But the building itself will just be the incinerator half will be a large open bay concept.
Alan, one thing, understanding that the site conditions between the Bissell facility and the Lemay facility are quite different. Can you just briefly comment on what those constraints will entail from a overall solids processing building perspective?
Sure. Bissell Point is, I'll say, pretty straightforward. It's a relatively level site. There's nothing there. So it's pretty clear, pretty easy to get the new building in there. There will be a basement level, but then the floor, if you want to call it the ground floor for the incinerator reactors, will essentially be existing grade out there now. Not a lot going on there. Lemay is a little bit more complex. That sits on a hillside on an existing slope, and also sits where our building is right now. So we will have to build this new building into that slope. One thing that does do, though, is it gives us the opportunity to take almost like a split level house, multiple access points into that building from multiple different levels. So we'll take that into consideration with the layout, and you'll see that in some of these upcoming sections that we show.
Sounds good. Thanks.
So this is a typical building section that came out of our Revit model for the solids processing building. Let me just reiterate one more time that keep in mind these are all works in progress, and I'm sure by the time this RFP ends up on your desk, it might look a little bit different than what you see now. But this just gives a good idea as to what we're planning on doing with the building. Just really quickly, as I'm looking at the slide, the left-hand side of it is the dewatering half of the building, basement level at the bottom with the receiving tanks and some sludge pumps that pump up to the centrifuge level, which is at the top. And then the right-hand side of the slide, as you look at it, is the fluidized bed reactor and all the components associated with that. And like I said, one thing that's really not shown on this sketch, but we will pick up, is we'll show a lot of intermediate platforms to make sure that we get the access that we need to key components of the incinerator side of the building. And then this is a typical floor plan layout that we'll have. This particular one is the centrifuge level for Bissell Point. Really what I want to point out here is what you don't see. We will show equipment and room layouts and things like that, but we don't show dimensions. We don't show, specific room sizes. We don't show any piping that interconnects all of this equipment. All that we intend to do with this layout is show you what we think is a good functional layout that will make everybody happy for this particular equipment. The particulars of tying all that together, of completing the layout of the rooms, of doing the piping design, that will all still be the responsibility of the design build teams.
Within that context, Alan, for an example, though, comment on how prescriptive the design guidelines may provide as far as the room sizes or room functionality, so that the teams are all playing from the same level, same playing field.
Yeah, so to complement these drawings, we will have design guideline sections. And in those design guideline sections, we'll have essentially room schedules that will list these individual offices. This particular sheet shows a conference room, a break room. And then it will say, this particular office needs to be home for one person plus maybe a small conference room table. The conference room needs to hold 10 people plus various technology, be it screens, projectors, whatever. And so working together, those design guidelines with this section, we'll give a lot of information for these rooms and this layout, but we're not going to give final room sizes. We're not going to give exact dimensions. So long as the requirements that we define are met, then there'll be flexibility beyond that to make this space work as someone else might see fit.
Gotcha.
And similar to the dewatering side of the building, this is just a typical floor plan arrangement that we're going to have for the incinerator side of the building. Really what I want to point out here is we do define a little bit better some of the expectations that we'll have in terms of dimensions and space layout. For this level, we feel it's important to have adequate space to move things around, to get access to all the different components of the system. One other thing that potentially could happen down the road for this project is things that are not included now, such as energy recovery, could be added later. So we do want to have areas set aside for that. So we will make sure that that is made clear on these plans. But outside of that, you'll see that this is just a typical arrangement that we expect for 4 trains for the incineration process and how they integrate with each other, and then how we also provide enough access and means of movement inside the building.
Some of the design build teams may have questions about how prescriptive we are with respect to, for instance, the maintenance and operation and maintenance room required for each of these processes. Can you comment on that?
Yeah, and that is critical. That is something that is very important to the district is access and maintainability. So again, complementing these drawings will be the design guidelines section that talks about the incineration process. And in there, we will give more detailed requirements for, I had mentioned earlier, access platforms and stairwells and where those platforms need to be. So, and generally how much room is necessary to move around inside the space. So those design guideline sections will do a much more detailed job of defining how we want access to be and just making sure that, you know, this building is not tightened up so much that it's impossible to move around.
Okay.
Next couple things I want to talk about are site plans and demolition. For these items, we've presented a lot of this in previous presentations, so this really isn't going to be new to most all of you, actually. Really what I want to point out with some of these site plans is frankly what we're not intending on doing. We will locate the solids processing buildings in the areas that we think fits best. We will describe what needs to be demolished, but we will not show things like final topography, final grading plans. We will show some general concepts for access around the buildings with road, but we will not do any road design or sidewalks. We will not do any stormwater design. Those will all be part of fitting in the design build team's design, how they want the whole project to, or excuse me, the whole site to interact with the existing facilities as well as the new building. And then one other thing I do want to point out with these plans, though, is we will, to the best we can, show existing utilities, existing process piping, existing plant piping. So it's known where available potable water is, where existing sanitary systems are at, existing stormwater systems are at. So the new facilities can be tied effectively into existing facilities.
Okay, great.
And the next slide will be Lemay. Again, nothing new to say here. Solids processing building located in the area of the existing maintenance facility. Final grading, final topography will be a lot more involved in this design because of the natural topography of the site as it slopes from. And realistically, this is the, I believe, the south side of the building towards the north side of the building. Right. One thing that I want to mention specific to Lemay is the new maintenance facility will be constructed with the demolition of the existing maintenance building. And that is in the area of the grit and screenings building, which is the grade screened facility on the lower right of this slide. And then if you want to go to the next slide, this will show a section for the Lemay maintenance facility. Right now, if you've had the opportunity to go into this building during some of the site visits, you'll see that it's essentially a building at grade, but then it's got a large pit, what I call a large pit in it. So we will take advantage of that at grade level, but then we will construct intermediate floors in the area of that pit so that this then becomes kind of a multiple level building where they can house a lot of the existing maintenance building facilities and transfer them into this new facility. The shell of the building will essentially stay the same. It's just that all the equipment on the inside of it will be taken out, and then these floors will be extended to give this multi-level building.
Alan, one question that some of the design build teams may have is what kind of flexibility will they have to incorporate different revisions to this, original concept that we have here? Perhaps, some of the rooms that we've defined on one floor being able to take to another floor and so forth.
There will be flexibility. I think I probably should have mentioned more at the outset, but anything that we are providing here is what we've been referring as a representative design that defines what we think is the best functionality, the best performance, the best quality for the project. But that isn't necessarily set in stone. And there will be opportunities for functionally equivalent designs that we will take a look at. So for example, in this building, it certainly makes sense to have certain areas grouped together, locker room areas with offices, with lunchrooms, with conference rooms. So it would be best that those kind of sub areas move together if they get moved from floor to floor. We have large overhead doors in this building, which would only make sense to continue to reuse as like a garage space. And there's another large overhead door that has an overhead crane nearby. So we'd obviously keep that area as some sort of unloading facility. But the other areas can be shifted around as seen, so long as we maintain that functional equivalence. That's the term we're using.
One other component about this building, and you mentioned, Alan, earlier that for its original purpose, it's been abandoned for some time, but it has remained active for at least a couple of rooms for another component, and that there's electrical rooms which serve other parts of the treatment facility. Can you comment on what will be done with those?
Yeah. The building has been abandoned for a long period of time, so it only has very rudimentary services right now. The plumbing would have to be improved, the HVAC system would have to be improved, the electrical would have to be improved. But yes, there is a component of the existing electrical room which feeds power to the adjacent UV facility on the nearby at the plant. So we have to make sure as we repurpose this building that some components of that area maintained in service while we do some upgrades to other components of it.
Gotcha. Okay.
And then with this slide, I wanted to just touch upon some of the other major design disciplines, obviously, that will be a part of the project. I've really only been talking about the solids processes, both the dewatering process and the incineration process. With architectural, we will give what we see are good fits for the architectural, I'll call it look or finish of the building. And we will list a couple different alternatives that should be used. As an example, we don't want metal flashing siding for all of these buildings. So that is not something that we'll want. So we just make sure that we will list items that we think work best for this area. Architecturally, like I've shown in some of the other plans, we'll show some basic room layouts, but those will be combined with room schedules in the design guidelines. And those room schedules will do things like indicate how many locker spaces are required in locker rooms, what the finishes need to be for different rooms, what conference rooms need to look like with wall finishes, floor finishes, stuff like that. So we will indicate a lot of that architecturally. Structurally, we really won't do too much. We will make sure that any parts of the solids processing building are buildable structurally. We don't want to have something that we put out there that comes back and says, well, this isn't possible to do structurally. So we'll take a basic run at column lines and column grids and just making sure that there's nothing that prevents these buildings from being constructed and laid out the way that we think works best. We will provide nothing on foundations. So that will be completely 100% up to the preferences and what they think best, the design build teams. To that end, we have done geotech programs and geotech investigations at both treatment plants. Those were completed this past summer 2021. And those reports will be included with the RFP. So those will be available for design builders to review. If they feel as though there's not enough information or they want some other areas outside of what we investigated, They will have the chance to go in and do their own geotech work as they're preparing their proposals. HVAC and plumbing are pretty straightforward. We really won't get into hardly any design on that. With the one caveat I will say is unique to Lemay, there are several buildings at the plant which receive building heat through a steam system, which essentially comes from their existing multiple hearth furnaces, their multiple hearth incinerators. So when those incinerators go away, the boilers and everything associated with that steam system become unusable. So we now have to provide building heat for those facilities. And that will be described also in the RFP documents, how we and what we need to do for building heat in those particular areas. On the electrical front, we will provide preliminary one-line diagrams, a couple of them, that essentially start with the utility feed into the plant, go through the medium voltage distribution, go through some of the medium voltage loads, and then even take it down to the low voltage distribution. But downstream of there, we'll leave that up to the design build teams. We'll want to make sure that we get what we believe is the best fit electrically for distributing power across the site. But once we get into the more individual feeds, that will be left to the design build teams. One thing I do want to mention electrically is there will be a period of time at the end of this project where the multiple hearth incinerators will still be running and power will be required for them and all of those processes while the new fluidized beds are being started up. And so we'll have to make sure we have power for both, and we'll have a concept shown in one lines for how to address that. So that will be included as part of the electrical design. And then lastly, on the instrumentation and controls, the big thing that we want to make sure everybody understands is how the new systems will interface with the existing plant control system, both Bissell Point and Lemay. So we will have descriptions of existing plant control systems. We will have key coordination items that we see need to be done between MSD as the owner and the design builder. MSD, as many of you know, do their own programming of PLCs, of HMIs. And so any coordination that is required to do all that, we'll make sure it gets defined so everybody understands what needs to be done for INC. We'll provide very basic P&IDs. We'll provide very basic IO lists to the point of just generally defining what we see for controls. But those general P&IDs will be expected to be starting points for design build teams, and then they will take those items to complete design based upon their specific design concepts and their specific layouts. And all of this will be defined. There'll be design guideline sections for each of these different components. So to be blunt, we want to make sure that no one just goes to Home Depot and buys conduit off the clearance rack. So we're going to have expectations for quality, for performance, for long-term reliability, again, to make sure that 5 years, 10 years, 25 years from now, the district as the owner is still happy with this project.
Very good.
So this again is just an example of what you'll see in this particular situation, a P&ID. Somebody might call this a P&ID light, but it will just show some of the major control items that we expect need to be addressed as part of the design. But if you really look at this drawing, you'll see it's kind of empty in some ways as well. There's still a lot of controls that need to be added, a lot of valving, stuff like that, instrumentation. So all that will still be the responsibility of the design builders. Just we'll give them something to start with.
Okay.
And the same applies to electrical. Again, we talked about starting with the main utility feed into the plant, how we tie into that, how we feed to a medium voltage distribution system, and then ultimately to a low voltage distribution system. So we'll have a couple one lines. This is again just an example that show all of that.
Sounds good. Thanks. Alan, obviously, we've kind of communicated this before to the design build teams in the informational meeting and so forth, but we've been developing as part of this project a 3D Revit model. Could you comment on how far that's going to be taken and the fact that it will be made available to the design build teams to incorporate and modify as they need to and want to?
Sure. Yeah, like you said at the outset, we're doing a conceptual design, and we want to make sure that this conceptual design that we present doesn't have any major flaws in it. So we certainly have started a Revit model. A section of it you can see here. It's 2019 Revit for those of you who need to know that. And with the RFP, we will make that available so that the design build teams can use that as a starting point and modify, or at least get an understanding of some of the concept that we have for laying out this building. So this particular rendering here just shows a section of Bissell Point's incinerator side with its 4 incinerator trains, multi-levels. And the next slide will show a couple other items specific to dewatering, specific to one single FBI train. And again, you know, just as much as we, all the design build teams will like to have this to start, we certainly have started with one to make sure that the design that we are proposing, quote unquote, works. And we'll make this available for everyone else to start with.
And generally speaking, the layouts that we've incorporated here are going to be consistent across the board for both facilities, correct?
Yes, there'll be a lot of similarities, yes. And then I've been really talking about some specific items to Bissell Point, to Lemay, to dewatering, to incineration, but there are some other items that are more big picture focused, big project focused. We get a lot of questions about addressing hazardous materials across the site, especially when it comes to demolition. We do know that there's asbestos containing materials across the plant. Rather than the district getting involved in trying to identify all of that and making that available to design build teams, we thought it best that we just put that in the responsibility of the design builders to identify the materials, to come up with a plan to remediate and remove all of that. And more importantly, doing it so that it coordinates best with their schedule and with their ongoing demolition work. So there will be part of the design builder scope is to address the hazardous materials. I touched upon at the very beginning of the presentation, we will make as-built drawings, reference drawings available, so I really don't need to say too much about that now. The flexibility with design, I kind of touched upon that too. What we're showing on these drawings, on these renderings is a representative design of what we think is the best for the long-term success of the project. But it's not set in stone. And there certainly will be opportunities for other people with other ideas to come in and make some of that. What we'll be looking for is what we're calling a functionally equivalent design. So you might have some different ideas for how to lay out the centrifuges, but so long as it still gets cake into the reactors, you know, we'll be open to that. So you touched upon alternative technical concepts earlier, Bentley, and that kind of goes into that. And then lastly, something else that's a very important part of this project is these are existing plants. The treatment process never stops. There'll always be solids coming in. There always need to be solids that go out of the plant. The district does not have any other place to put these solids. So sequencing all of this work with existing facilities is going to be critical. And some things are, quite frankly, rather obvious. You know, you can't build a new solids processing building at Lemay until you knock down the maintenance building first. But there are other things that I want to make sure everyone else understands, which might be a little bit more taken into consideration is, for example, at Lemay, the existing main plant control room is in their INF building, which eventually will come down. So there'll have to be some thought given to coordinating with MSD, relocating that facility, that room from the old facility to the new building. And then even something that might not be thought about too much is the Bissell ash lagoons. The ash never stops. So any work that's done there will have to be fit around maintaining operation and the functionality of those basins. You know, a demolition is a big part of this project. So it has going to have to be thought out pretty thoroughly.
Thanks, Alan. Also, I mentioned at the outset that we would be making the conceptual design report available as part of this presentation. Alan, you want to comment on kind of what that's going to include? Just a preview.
Yeah, you touched upon it a little bit at the beginning. We called it a conceptual design report. Other people might call it a basis of design report or a pre-design report. But it kind of puts all into one place, all of the decisions that we've made for the technical components of the project. It'll talk about how we got to where we are and what we expect for dewatering, for incineration, for locating primary or sludge wells, things like that. So there'll be that type of information available for everyone to take a look at. It'll be supplemented by technical memorandums that we prepared over the course of the project. And one of the big things that we want to put out there is there will definitely be design builder ideas that you will want to present, but you might see in the conceptual design report that we've already addressed that or we've already discussed it. So you will probably know then off the top that that was kind of a no-go and it might not be worth your time to put a little bit more effort into it. But opposite from that, if it's something that you don't see that we might have not have discussed because it's not in any of these reports, it certainly could be something that we're open with. So that report will be made available, and what you have here on the slide for its location in that website will be where it's at.
And that is the project website that I'm sure everyone is familiar with at this point in time. Anyone that's watching this presentation anyway. So, all right. Again, I want to thank you. Thank each of the design build teams for your interest, and we hope that this information, including the CDR, provides you with some relevant information that you can use to enhance your design and approach. Overall, the 30% design is being finalized as we speak and will be completed and released with the RFP documents. Those documents are scheduled to be released with the notification to the shortlisted teams, which is currently scheduled for March 17th, 2022. As always, please let us know if you have any questions, and we look forward to working with you. Thank you.